So in the previous videos we have looked at reactions of alkanes through complete and incomplete combustion. However, these are not the only sort of reactions that alkanes can undergo, and in fact they can undergo reactions that will form halogen alkanes. And this type of reaction is known as radical substitution. Free radical substitution is the technical term here. Now, essentially, the idea of it is an alkane reacts with sort of both chlorine and bromine in the presence of UV light or extreme temperatures, and this halogen forms a radical. So what is meant by this term radical here? Well, a radical is just a reactive species with unpaired electrons. Just a reactive species with unpaired electrons. Just one more thing to talk about before we get into the midst of our reactions. There are three stages to this free radical substitution. Stage 1 is called initiation, where we will see the UV light sort of as a catalyst in breaking the catalyst. It sort of initiates the reaction. Step 2 is going to be propagation. This is where the main chunk of our reaction happens, and the ending of our reaction is given by step 3, which is termination, and our desired and definitely some undesired products are formed. Which gets into my point that radical substitution is very unpredictable and difficult to control. They're random because of the reactive radical produced in the initiation, which could collide with other species that we don't want. And by species I just mean, intermediates, other reactants that we don't want, and a mixture of products are actually formed from this type of reaction. So yeah, not a very high yield of desirable products. Right. So let's get into a reaction. So I'm actually going to start with just a basic cure here. We'll start with maybe some methane here. And we'll also start with maybe a molecule of chlorine, so Cl2. And so how this reaction first starts off, we have a Cl and a Cl. So I'm going to draw the curly arrow reaction mechanism for this reaction, and then I'm going to draw just a very quick reaction mechanism, which will be better for you guys to draw. So obviously we're going to have some homolytic fission. There's some UV light coming down here, and it's breaking this covalent bond, and we're going to have some homolytic fission, and this is going to form two chlorine radicals here. Now what's going to happen with these radicals? So what I mean by I'm going to show you a more simpler version. I'll do it on this side, where we can literally just write Cl2, and that goes to form our two chlorine radicals. Now what can happen in this first step is known as our initiation reaction. We're creating the radicals here. Next step, we have propagation. So here we have our CH4, our methane, it's actually going to react with one of the chlorine radicals. And what this is going to do is, if I show you here, up here, we're just going to draw a chlorine. And this, a pair of electrons is actually going to come over here and bond with this, as the electrons coming over here. So this is actually, as this breaks, we're going to form a sort of methyl radical and hydrogen chloride, hydrochloric acid. Okay, so this is going to come over and we're going to form CH3. Draw the dot here to mean the radical. HCl, and this is actually the simplest way of drawing it. And there's 2 steps to a propagation reaction. The second being, this CH3 radical actually combines with another chlorine molecule to here, combines to another chlorine molecule, and this produces our CH3Cl plus another chlorine radical. There. So we can see we've obviously formed our chloromethane here. Propagation. This is our propagation step. See, we've obviously formed our chloromethane, and we've already also created this chlorine radical. So you can see how this reaction could continue on for a large amount of time. Maybe this chlorine radical finds another chlorine radical, and they both react and form our Cl2 molecule again. Or maybe our methyl radical here doesn't react with another chlorine. Instead, perhaps our methyl radical reacts with another methyl radical. And here we have C2H6. So actually, ethane is produced. But perhaps our methyl radical does react with a chlorine radical. And hence our desired product is created here. And so termination is just an overview of all the different reactions that could occur from just this one radical breaking here. So this is just this. I'm going to be creating another video just showing sort of more complicated steps in this reaction, but hope you enjoyed and look out for that video.